Hey Google, I just wanted to ask you, how old is the universe?
13.8 billion years.
And if we go to NASA's website, it says the same thing. But how? To understand how it all started, first we need to know how the universe began. Of course, we don't really know how it began, but there are theories, and one of the most famous ones is the Big Bang Theory. The universe is not just space and stars. The universe is space, time, energy, even the laws of physics themselves. So, what is the Big Bang Theory? It is not a bomb explosion, and it's not something that exploded inside the universe. It is an expansion. The whole universe was once a very hot and very dense point. Then it started to expand. It did not stop expanding, and it is still expanding until now. To simplify the idea, imagine a balloon with dots on it. When we blow it up, the dots move away from each other, not because the dots are moving, but because the balloon itself is getting bigger. Now let's see how scientists reached this theory. The first thing that made scientists think the universe had a beginning was that they noticed something strange. They saw that galaxies in the universe are not staying in one place. On the contrary, almost all galaxies are moving away from each other. And not only that, the farther a galaxy is, the faster it is moving. So what does this mean? It means that if we go back in time, these galaxies must have been closer and closer to each other, until we reach a point where the universe was much smaller. The second evidence explaining light needs time to travel. To simplify the idea, let's imagine an object that is 100 meters away from a person. For this person to see the object, light has to reach the object, then reflect off it and come back to the person so they can see it. This means the person is seeing the object in the past. In just a fraction of a second, the person will see the object because the object is close and the speed of light is very high. But if we take this idea on a much bigger scale, like galaxies, those galaxies are extremely far away from us, so light needs a very long time to reach them and then come back to us so we can see them. This means we are seeing galaxies the way they were millions or even billions of years ago. The third evidence, and the most important one. So, if the universe was really smaller and hotter at the beginning, there should be some effect of that heat still present today, right? In the 1960s, scientists discovered something strange. A very weak radiation coming from everywhere in the universe. Not from a star, not from a galaxy, but from all directions with almost the same strength. At first they thought it was noise or a problem with their equipment, but later they discovered that this radiation is real. This radiation is the leftover heat from the early universe. It is called cosmic background radiation. It is as if the universe kept an old picture from its childhood. Why is this evidence considered the most important one? Simply because the existence of radiation coming from all directions with almost the same properties can only be explained by a universe that was hot at the beginning. Now let's talk about how scientists calculated the age of the universe. There are two ways scientists were able to calculate the age of the universe. The first method, which is the more accurate one. Look, my friend, with the development of telescopes, scientists noticed something strange. They noticed that stars in distant galaxies have a color that shifts toward red, and this is not supposed to happen. Why? Every chemical element, when it gains or loses energy, emits light in specific colors. From our study of nearby stars like the Sun, we know that stars are mainly made of hydrogen and helium. But these two elements do not emit these strong red colors. Yes, hydrogen gives off a little red, but not like what we see through telescopes. This means one of two things. Either these stars that appear red have a different composition, and this is unlikely, or the color difference is caused by the movement of the stars. Look, my friend, if an object is emitting light and moving away from you, the color shifts toward red. But if an object is emitting light and moving toward you, the radiation shifts toward blue. This happens because when an object moves away, its wavelength stretches, making it appear red. And when the object moves closer, the wavelength shrinks, making it appear blue. Now, based on what we know, that the universe started from a single small point, that the universe is continuously expanding, and that we can calculate the rate of expansion by measuring how fast stars are moving away from us and their acceleration, we put all of this into a mathematical equation, and this gives us the age of the universe, 13.8 billion years. Now let's move to the second method, which is approximate and not very accurate, but it supports and confirms the first method. If we look for the oldest star ever observed, and its age is a certain number, then the universe must be older than that number. The oldest star observed by scientists is 13.6 billion years old. This number is very close to our first calculation, which means the first method is more likely to be correct. Now, my dear viewer, I want to ask you, did all of this happen by coincidence? Of course not. There is a creator for all of this, and that creator is Allah, with no one else. And you, my dear viewer, can search and see that the Quran, which was revealed more than 1,400 years ago, at a time with no advanced technology and no telescopes, contains verses that confirm the idea that the universe was once compact at the beginning, and also confirm that the universe is continuously expanding. At the end of the video, leave a like and subscribe to the channel, and wait for me in the next video.